Hello, Algebra 2 students. So we are going to finish going over our review from where we left off in class. And the last thing we talked about in class was how to get this value. We just did not write down what that value is. And when you multiply the 26 by 25 times 24 and 10 to the third, you should get 15,600,000. Alright, so now we'll go to 14. So 14 we're just going to evaluate. We know we have 9 factorial here, and then 6 minus 3, because this is in parentheses, it is the same thing as 9 factorial over 3 factorial times 6 factorial. And we can use the factorial function on our calculator. But in order to make that a little faster, sometimes what I like to do is write 9 out is 9 times 8 times 7, and then this will be times 6 factorial, like 6, 5, 4, 3, 2, 1, because that way I can cancel out the two 6 factorials, and then I can just do the 9 times 8 times 7, which is going to be 504 over 3 factorial, which is 6. And when I divide, I will get 84. So for 14a, you should have 84. Okay, now for b, 8 factorial times 5 factorial. These are not in parentheses, so we do have to do that out separately. Negative 3 plus 3 is 0 factorial. 0 factorial is equal to 1. So really what we have to do is figure out 8 factorial minus 5 factorial. That would be a great time to use the factorial function on your calculator, so I will show you how to do that. So I'm going to type in 8. We're going to go to math, arrow over to probability, and then here's our factorial button. So we have 8 factorial. You can press enter now, and then minus the 5 factorial. Again, over to math, probability, factorial. Right, and then we'll get 40,200. So be careful, because usually what people will mess up on is they'll say that's 3 factorial, but it's not. This is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 minus 5 times 4 times 3 times 2 times 1. Okay, and then as you can see, that's going to be a lot bigger than 3 factorial, which is just 6. Alright, for 15 it says Vince chooses 3 side dishes from a total of 10. How many different ways can he choose his side dishes? So we have to ask ourselves, is order going to matter or is order not going to matter? If he's just choosing side dishes, it doesn't say anything about an arrangement or a schedule, so the order is not going to matter. So think about when you go to a restaurant, right? If you order French fries and macaroni and cheese and a salad, it doesn't matter the order that you tell the waitress, they're all coming out at the same time. So if it's not matter, then we're going to use the combination. So out of 10 choices, he's going to pick 3 of them. And then remember, we can use 10 combination 3. So we'll go to the probability. 10 combination 3 is going to be 120. And that's how many different ways Vince can order. For 16, you have the door code to a top secret laboratory. It's 6 digits. The first 3 digits are all odd, and the last 3 are all even. Digits can be used more than once. How many possible codes are there to gain access to this laboratory? So let's write out what all of the odd digits are, and then all of the even. And you probably already know how many there are. Remember, there's 10 digits total. So the ones that are odd would be half of them. There'll be 5, but I'm just going to write them out to show you. So the odd digits, 1, 3, 5, 7, and 9. So 1, 2, 3, 4, 5. So it says the first 3 digits are all odd. So 1, 2, 3. So I have 5 choices for the first, 5 choices for the second, 5 choices for the third, because they can be repeated. If they couldn't, then it would be 5 times 4 times 3. And then it says the last 3 digits are all even. Well, how many even digits do you think there are? If you aren't sure, write them out, right? 0 is an even digit, and then 2, 4, 6, and 8. So 1, 2, 3, 4, 5. So for every even digit, that's going to be 5s as well. So really, this is 5 to the 6th power, and 5 to the 6th power is going to be 15,625, and those are going to be the amount of codes that are possible. All right, for 17, using a fair coin and a fair 6-sided number cube. So fair just means they're all equal. What is the probability of tossing tails and rolling a multiple of 3? Okay, so if it's tossing tails, you have to ask yourself, what's the probability of that? So the probability of tossing tails would be 1 out of 2, okay, or 1/2. Then we're going to multiply that by the probability for rolling a multiple of 3. So we have to ask ourselves, okay, what are the multiples of 3? And multiples of 3 on a 6-sided number cube, if we have 1, 2, 3, 4, 5, 6, that means we have 6 options total. Multiples of 3 include 3 from 3 times 1 and 6 from 3 times 2. So there's 1, 2, 2 out of 6, or 1/3 if you want to use the reduced one. So this would be 1 over 6. That would be your final answer. If you didn't reduce right away, even if you did 2 out of 6, you would get 2 over 12, which would reduce to 1 over 6. Okay, so rolling a multiple of 3, remember multiples of 3 have to be 3 or greater. It's any number that can be multiplied, 3 and another number. So 3 times 1 is 3, 3 is a multiple of 3. 3 times 2 is 6, 6 is a multiple. Okay. All right, so for 17, 1, 6 is our final answer. For 18, a coin and a number cube are tossed at the same time. What's the probability the coin shows tails and the number cube shows a 2, 3, or 4? So the coin shows tails, what's that probability going to be? So the coin shows tails, that's going to be 1 out of 2. So we just did that one with the problem before. And it says the number cube shows a 2, 3, or 4. So a number cube, if there's just one of them, there's going to be 6 choices. If you have 1, 2, 3 out of 6, that would be 1/2. So really, it's going to be 1/2 times 1/2, or 1/4. So you have a 1/2 chance of getting tails. You have a 1/2 chance of rolling a 2, 3, or 4 out of the 6-sided die. And so when you multiply 1/2 and 1/2, you're going to get 1/4. All right, for 19, you have 2 number cubes that are rolled at the same time. Remember, anytime you have 2 number cubes that are rolled at the same time, there's going to be 36 possible options because each one has the probability of 6 on the bottom. So 6 times 6 is how we get that 36. You can also, you probably remember that chart with the red and the blue number cubes in our textbook where they list out all the options for you. So we're trying to find the approximate probability that the sum of the 2 cubes is either 2 or 12. So let's go through and see if we can find any that have the sum of 2 or 12. So first let's start with the ones. So 1 and 1, that's going to be 2. And then I would go through 1 and 2, nope, 1 and 3, 1 and 4, 1 and 5, 1 and 6. All right, so 1 and 1 is the only 2 numbers that are going to add up to 2. 2 and 0 would make 2, but 0 is not going to be on the number cube. 2 and 10 would make 12, but that's not on the number cube. And in fact, the same thing's going to happen with 3, 4, and 5. So the only other option that we'll have would be if you roll a 6 and a 6, because that's going to be 12. So I go through that entire chart in my head and I say, okay, here's one option, here's 2 options. So I have 2 choices, so 2 out of 36 is going to reduce to 1 out of 18. So my final value is going to be 1 out of 18. Right? And if you are having trouble visualizing that, if you go to your textbook and you look up where that red and blue chart is, you can see all 36 options, and you can look at all of them, and you can tell which ones are going to add up to 2. If you don't have your textbook, an easy way to write it out, it's just 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, and then you do the same thing with 2. So 2 and 1, 2 and 2, all the way down, and then 3 and 1, all the way down, 4 and 1, 5 and 1, 6 and 1. And you could actually make your own from there. All right, so it says if a coin and a number cube are tossed at the same time, what is the probability of tossing heads and rolling an even number? So first let's do the possibility of heads. So that's going to be 1 out of 2, and then we're going to multiply that by the probability of rolling an even number. So that would be, you could either think of it as 6 on the bottom, 3 on the top, so 3 out of 6 are going to be even numbers. Because if it's even, you could roll a 2, a 4, or a 6, or this is going to reduce to 1/2. So this is 1/2 times 1/2, which is going to be 1/4. So 1/4 will be your final answer. Okay, so see how I do both of those probabilities, and then we're going to multiply them together to find that final probability. All right, for 21, it says, what is the exact probability? So if it says exact, that means we are not going to round. We're going to leave everything in terms of pi. So what's the exact probability that a point chosen inside the rectangle is inside the shaded region? So what we have to do is we have to find the shaded and put that over the total, and that's going to be our probability. So look at the shaded region. You can see that the shaded region is going to be the entire rectangle, except I have to minus these 2 circle areas. And then the total is going to be the rectangle itself, which if I have 3 feet as my width and 5 feet as my length, the total is just going to be 5 times 3, or 15. So that's going to be in the denominator when I make my final fraction. And then the shaded is going to be the area of the rectangle minus the area of circle 1 and minus the area of circle 2. Now both of these circles actually have the same radius, so you could actually just do minus 2 times that circle. And then on the bottom, the total, like we said, this is just the area of the rectangle. Okay, so the area of the circle is pi r squared. So pi, our r value is 1, so 1 squared is 1, so that'll just be pi. The area of the rectangle is 15, so I have 15 minus pi, which is 15 minus 2 pi. Okay, so pi and pi is going to be 2 pi. So you can leave your answer as 15 minus 2 pi over 15, since it says that's our exact value. Or if you wanted, you could actually simplify this. This would be the same thing as 15 over 15 minus 2 pi over 15. And really, 15 over 15 is just going to be 1. So 1 minus 2 pi over 15, that would be acceptable as well. So because it says exact, okay, that means that you're not going to round. So do not round. You're going to leave in terms of pi. Okay, so you should have pi in your final answer. All right, for 22, Julia's trying to figure out how many outfits she has for a summer vacation. If she packs the following items and wears one of each per day, how many days can she wear an outfit without repeating? So what we can use here is the fundamental counting principle. So the shirts that we have 1, 2, 3, 4. We can multiply that by the number of shorts. She has 3 pairs of shorts. She has 3 pairs of shoes. She has 3 different pieces of jewelry she can wear. So we're going to multiply those together. And really, 3 cubed is going to be 27. So we're doing 4 times 27. Do you guys know what 4 times 20 is? 80. 4 times 7 is 28. So that would be 108. So she has 108 different choices. For 23, you have a red number cube and a blue number cube that are rolled. Find the probability of each event. So if you're rolling a red number cube and a blue number cube, what is going to be the denominator here? If you have two of them, the denominator is going to be 36. There's always going to be 36 possibilities. So it says the result is 2 2s. So if you go down your list, okay, in the 1s column, there's going to be nothing there. In the 2s column, it'll be 2 and 2. So that's one choice out of 36. That's the only time you'll roll 2 2s. So 1 out of 36 is going to be the probability. Now for B, it says the result is a 2 and a 3. So if we're going down the columns, if we start with 2, you could have a 2 and a 3. If we go in the 3 column, you could have a 3 and a 2. So that's going to be 2 choices out of 36, and that reduces to 1 out of 18. For the last one, it says the result, it should say the result, it says is an odd number. We're going to do the result is an odd number and an even number. Okay, because you have to have two different things, so I'm sorry, that one should have been corrected. So if the result is 1 odd and 1 even, let's start with the ones. So you could have 1 and 2, you could have 1 and 4, or you could have 1 and 6. So that's an odd and even. For a 2, you could have 2 and 1, 2 and 3, 2 and 5. Okay, that will give you 1 odd, 1 even. For the 3s, you can have 3 and 2, 3 and 4, 3 and 6. For 4, you could have 4 and 1, 4 and 3, 4 and 5, which I think you guys can start to see the pattern. So every single column is going to have how many options? Yep, it'll have 3. So 6, 1, 6, 3, 6, 5. So let's count up how many we have, where we could just 1, 2, 3, and then 1, 2, 3, 4, 5, 6. There's 18. So 18 out of our total of 36 is going to be 1/2. Okay, so then 1/2 is going to be our probability. For 24, Mr. Feeney is passing back history tests. If he gives them out randomly to the 8 students in the class, what is the probability everyone gets the correct test? Okay, so think of the first person. If he has 8 tests, he has a probability of 1 out of 8 choices that he's going to get the right one, because there's only one that's the correct answer for a student. The next person, now that he's already passed one back, he has 1 chance out of 7 to get the correct one, then 1 out of 6, then 1 out of 5, 1 out of 4, 1 out of 3, 1 out of 2, 1 out of 1, which really, look at the bottom. It's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is really 1/8 factorial. Okay, so let's do 8 factorial. If we do 8, and then we're going to go to math, arrow over to probability, and you should get 40,320. So he has a 1 in 40,320 of a chance that he's going to give them back to the correct students if he just does that randomly. All right, for 25, in a box of 18 pencils, there are 4 already sharpened. What's the probability of selecting a pencil that is not already sharpened? Well, if 4 already are sharpened out of the 18, what we can do is, because we're doing the not already sharpened, we can use the complement. So 1 minus 4 out of 18, because 1 represents 100%. So this would be like 18 over 18 minus 4 over 18, which would be 14 over 18. And now is that going to reduce? Is there a number that goes into both of those? Yep, 2 does, so 7 over 9. So that's going to be your probability. All right, and then for 26, a student organizes her math assessment scores and comes up with the following data set. What is the experimental probability that a score chosen at random is below 80%? So first, let's count up and see how many scores she has. So if we count these up, she has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 is going to be the possible number, so that'll be in the denominator. And it says, what's the experimental probability that a score chosen at random is below 80? So I'm going to go through and I'm just going to circle the ones that are below 80. Notice that it says below, it does not say equal to. So 78's below 80. So 80 is not below 80, it's equal to. So I'm not going to circle that. 79 is below. And then I think that's it for all the ones that are below. So it's 3 out of 12, and that will reduce to 1 out of 4. So there's the probability of 1 out of 4 that a random score chosen is below 80%. Now, the next one for 27, the table shows the result of spinning a spinner with unequal spaces. We're going to write these as exact decimals. So exact decimals means we're not going to be rounding. So for 27A, it says find the experimental probability of spinning a 2 or a 4. So if it's a 2 or a 4, we're going to end up adding those together. So 31 plus 26 is 57. And if we total these up, we can find our total value. Okay, so 15 and 31 is 46. 46 and 4 is 50. 50 and 26 is 76. This would be 86, 87. This would be 90, 100. So 57 out of 100, what's that going to be as an exact decimal? 0.57. Okay, so it'll be in the hundreds place. And then the next one says, what's the experimental probability of not spinning a 2 or 4? So we could just do 1 minus 0.57, which 0.03 will get us to 60. So it'll be 0.43. Be the probability of not spinning a 2 or 4. That's the complement. For C, find the experimental probability of spinning a factor of 18. Okay, so factors of 18 are numbers that go into 18 evenly. So 1 goes in there evenly, 1 times 18. Does 2 go in there? Yep, 2 times 9. What about 3? Yep, 3 times 6. 4? No. 5? No. 6? Yes. So 1, 2, 3, and 6. So what I'm going to do is I'm going to add up. So for 1 there were 15. For 2 there were 31. For 3 there were 4. For 6 there were 13. If I add them all up, I get 63. So 63 out of 100 is going to be 0.63 as an exact decimal. And for the last one, the experimental probability of spinning an even number, so that will be a 2, 4, or a 6. So I'm going to add up 31 for 2, 26 for 4, 13 for 6, and I will get 70. So 70 over 100 is going to be 0.7, or even if you wrote 0.70, that would be perfectly fine. All right, so your actual quiz is only 18 questions, very similar to what's on this review. I just gave you extra to review. Everything is going to be worth 1 point, and there are a couple that have a part A and B, so each blank on there is going to be worth 1 point. And then make sure you just study your 7-1 and 7-2.